Dear students, today we're going to learn about stacks. What is a stack? So basically, a stack is a linear data structure which follows a particular order in which the operations are performed. Stacks follow the last in first out principle. The last item to be inserted into a stack is the first one to be deleted from it. The push operations push and pop occur at one end only, which is called the top. There are many real-life examples of a stack. Consider an example of plates stacked over one another in the canteen. The plate which is at the top is the first one to be removed. That is, the plate which has been placed at the bottommost position remains in the stack for the longest period of time. So, it can be simply seen to follow LIFO principle or the last in first out principle. Moving on, operations in a stack. The operations in a stack include push, which means adding an item in the stack. If the stack is full, then it is said to be in an overflow condition, while its opposite is pop, which helps us remove an item from the stack. If the stack is empty, then it is said to be an underflow condition. The items are popped in the reverse order in which they are pushed. Peak or top returns the top element of the stack. isEmpty returns true if the stack is empty, else false. Display, as the name suggests, displays all the elements present in the stack. Let us look at an example of a stack. Here we see a stack which has the elements 1, 2, 7 and 6. When we need to push 4 into the stack, it goes to the top. When we delete an element or pop an element, the same element is removed. That is the top element. Here is an example code of push. So the basically arguments here are stack, which is passed as an array, the value of the element, and the number of elements in the stack. For the if-else condition, if top is equal to n minus 1, which means that the position is at the last position in a stack and hence no more elements can be added, which means the stack is currently in an overflow condition. Otherwise, the following code is proceeded with. Top is equal to top plus 1, which means incrementing the top position. Stack of top at position top is equal to x, where x is the element, and hence the element is introduced to the stack. Pop. The arguments here are an array and the number of elements in the stack. isEmpty function, what it does is, like I told you earlier, it tells us if a stack is empty or not. If the stack is empty, then no more elements can be popped from it, and hence it leads to an underflow condition. Otherwise, the top value is decremented by 1. Top element, which as the name suggests, tells us whatever the element is at the top position. Size tells us the size of the stack. Stack empty isEmpty function is a boolean function, which means it only returns value true or false. It returns value true if the stack is empty, else it returns false. Applications of stacks. Some of the following are some of the important applications of stack data structure. Stacks can be used for expression evaluation. Stacks can be used for conversion from one form of expression to another. Basically, the forms are converting one form of expression to another is one of the important applications of stack. It includes infix to prefix, infix to postfix, or postfix to infix, and prefix to infix. Stacks can be used for memory management. The assignment of memory takes place in contiguous memory blocks. We call this stack memory allocation because the assignment takes place in the function stack called stack. The size of the memory to be allocated is known to the compiler. When a function is called, its variables get memory allocated on the stack. When the function call is completed, the memory for the variables is released. All this happens with the help of some predefined routines in the compiler. The user does not have to worry about memory allocation and release of stack variables. Stack data structures are also used in backtracking problems. Backtracking can be defined as a general algorithmic technique that considers searching every possible combination in order to solve a computational problem. Expression conversion. Converting one form of expressions to another is one of the important applications of stacks. Some of the types are infix to prefix, infix to postfix, prefix to infix, prefix to postfix, and so on. We'll look into infix to prefix and infix to postfix in this video. For an example here, a plus b, which is in the infix expression, which is an infix expression. To convert it into prefix, the operator comes to like left of the variables, which means pre, and similarly post, which means right of the element of the variables. In infix to prefix, for example, a plus b is an infix notation, then plus ab is the equivalent prefix notation of a plus b. These are the steps to convert infix expression to prefix. You can pause the video and note down the steps. Moving on, infix to postfix. For example, a plus b is an infix notation. Postfix, ab plus is the equivalent postfix notation of a plus b. These are the steps to convert infix expression to postfix. We'll look into an example now. This is the example. A plus b multiplication c minus b minus z multiplication f plus g. Look at the parenthesis closely. We can rewrite this as this expression. Now, to write the prefix notation of this expression, all we need to do is put the minus over here. Then, looking at the left side of this expression, comes a asterisk, which means multiplication, then a plus, and then a, b, and c in that order because it's a prefix notation. Then we move on to the right side of the expression, which means a multiplication due to the parenthesis. Then the minus, then d, e, then plus, f, and g. This is the prefix notation of the expression. Now, the postfix notation of this expression will be as follows. First, it will be a, b, then plus, then c, because a plus b is in a bracket or parenthesis. Therefore, a, b plus, then c, then asterisk or multiplication, then d, e, minus, then f, g, plus, then asterisk due to the parenthesis, and then the final operator subtraction, minus. Implementation of stacks. Stacks can be implemented using arrays and pointers. Now we'll learn how to implement a stack using an array. We use an online compiler for that, known as onlinegtb.com. First, let us change the language to C. Adding the header file. We'll initialize an array called stack, which can hold up to 50 elements in it. Then the number of elements, int, top, and then x, which will be the element in the push function. If top is greater than or equal to n-1, which means the stack is full and thus the stack overflow condition is generated. Else we need to take an input and the number or the element will be added to the stack. We can use \n to enter a new line. We use %d for taking input of an integer value. Thus the push function has been created. Now moving on to pop function. If top is less than or equal to -1, which means the stack is empty, then the underflow condition will be generated. Thus the pop function has also been created. Now the only function we need is display function to display all the elements in the stack. The display function has also been created. We used if-else statement over here to check if the if statement, basically top greater than or equal to 0, checks if the stack is empty or not. If the top is greater than or equal to 0, which means the stack isn't empty and hence all the elements as in the stack are displayed. Otherwise the function prints stack is empty. Now we'll move on to a main function. First of all, we'll have to initialize the value of top, which is equal to -1. Then int.ch, which will be my choice. I am creating a switch case statement to basically create a menu where the user can choose if he wants to push an element or pop an element or display all the elements present in the stack or just exit. We'll create a do while loop uh, because do while is an exit control loop, which means that at least the loop will be executed at least one time. So do we've created a statement to enter the choice, or basically input a choice from the user to take an input. A switch case has been created where case 1 is push function. For the fourth option, which is exit, we could have used exit and parenthesis 0, but we didn't use it as it requires the header file process.h. So we're just gonna print finished instead. And as default, we are gonna give that since there is no other option in the menu, it is probably an invalid choice or wrong choice. Enter again. Thus, we are done with the program. Let's run it. I'm sorry, I missed a comma. Okay, let's choose the size of the stack as 5 for now. Let's put 1 as a choice. Element should be 6, then 1 again. Element can be 7, 1 again. Element can be 3, and then we'll display the elements is 3, 7 and 6, and now we'll delete an element. It popped the element 3, which was the top of the stack. Now we'll display all the elements in the stack. As you see, 3 has been removed, and we've got 7 and 6, which are the remaining elements in the stack, and thus our program works. Uh, Now we'll enter 4 to exit the program, and it says finished, and hence it's now exit. With this, we've come to an end to our video, and I hope that you understand stacks better now. Thank you.